So continuing from yesterday, I want us to use synthetic division, and I want us to divide 30 minus 2x squared minus 2x plus 6x cubed. I want us to divide that whole thing by the quantity of 3x plus 5. Hey, first thing I want us to realize is the dividend is not in descending order. So let's fix that. So we're going to have 6x cubed minus 2x squared minus 2x plus 30, and we're going to divide that by 3x plus 5. 8. I'm still looking at the dividend. Is every exponent accounted for? Yeah, we have 3, we have 2, we have 1, and then we have our constant. So every exponent is accounted for. We always want to make sure of that. Right, then we're going to look at our divisor. Is there a problem with the divisor to use synthetic division on this? Yeah, there is a problem. I cannot use synthetic division at how it is right now. What's the problem? Matt? Good. The coefficient of x is not 1. That's the main problem right now. So anytime we come into this scenario, what we want to do is we're going to go to the divisor. We're going to pull out a GCF of whatever that leading coefficient is, even if it's not divisible by the rest of the divisor. So when I pull out a 3 here, we're going to end up with x plus 5/3. Does that make sense to everyone? Okay. Now, whatever I pull out in the divisor, I need to pull it out in the dividend so they can cancel out. So then those two, so the two GCFs can cancel out. So now I'm going to pull out a 3 in the dividend. So then when we pull out the 3, we're going to have 2x cubed minus 2/3 x squared minus 2/3 x plus 10. All right, so I pulled out the leading coefficient as a GCF in the divisor. I pulled out that same GCF in the dividend. Why? So I can do what with those? Since we're dividing them, same thing top and bottom. Can't we just divide them out? 3 divided by 3 is 1. Okay. All right. So now I can set up my synthetic division. Do we agree that this is the same as x minus negative 5/3? So then it's in that 1x minus a sort of format. Okay, so when I go to make the box, what number is going into the box? Dylan? Negative 5/3. You got it. And then I'm going to write out my coefficients. 2, negative 2/3, negative 2/3, and 10. All right, so now we bring down the first term, and we're going to say 2 times a negative 5/3 is a negative 10/3. Well, negative 2/3 plus a negative 10/3, isn't that a negative 12/3? But what's negative 12 divided by 3? Negative 4. So now I'm going to do negative 4 times a negative 5/3, which is a positive 20/3. So now I'm going to have a negative 2/3 plus a positive 20/3, which is, oh yes, 18/3, which is positive 6. All right, then we have 6 times negative 5/3, which is a negative 30/3. But what's negative 30 divided by 3? Negative 10. Positive 10 plus a negative 10 is 0. All right, so now we're going to write out our new polynomial. and it's going to be 1 degree less than the original. The original dividend had the power of 3, so this one will have a power of 2. So this is 2x squared minus 4x plus 6. That is our quotient. Yes.
On the test, will we be able to choose, like, if you want to do synthetic division or...
For some problems, yes. For others, I will tell you what to do. So you do need to know both. We did ones with I, right? Yeah, okay. All right, so now we're going to talk about the remainder theorem. All right, I'll write it out and then I'll explain to you. If a polynomial p of x is divided by x minus a, the remainder is equal to p of a. Write it down and then I'll explain to you what this means. Okay, so what this means, I'm going to do an example. I'm going to do it 2 ways. If I give you 6x to the third minus 5x squared plus 4x minus 17, and I take that whole thing and I want us to divide it by x minus 3. Or, hold on, sorry. We are doing that, but let's say I told you in the problem f of x is equal to 6x to the third minus 5x squared plus 4x minus 17. And then we're going to take that f of x and divide it by x minus 3. Right, let's first do this. We're gonna do this using synthetic division. So if we're using synthetic division, do we agree 3 is going in the box? And then we're gonna write out our coefficients 6, -5, 4, and -17. You all do this and tell me what you end up with. All right, what'd you all get as the remainder? Find the remainder. Sorry, did I say that? Find the remainder. Arish?
112.
112. I got that. Anybody want to see us do this? It's not. Okay, so what did we do? 6 times 3 is 18. -5 plus 18 is 13. 13 times 3 is 39. 4 plus 39 is 43. 43 times 3 is 129. Negative 17 plus 129 is 112. Aaron, you okay? Yeah. Tejas, you find your mistake? Yeah. Okay, so do we all agree the remainder is 112? Okay, what this theorem is telling us, that if I have f of x is equal to 6x cubed minus 5x squared plus 4x minus 17, and we are dividing it, divide f of x by x minus 3. Find the remainder. What this theorem is telling us is that if we take the divisor and we solve for the variable, so if we take the divisor, which is x minus 3, and solve for it, that would be x equals 3. And you plug that in. And you simplify that down, what you simplify down to will be the remainder. So we have f of x is 6x cubed minus 5x squared plus 4x minus 17. If I take f of 3, so now I'm substituting 3 in for x, that's going to give me 6 times 3 cubed minus 5 times 3 squared plus 4 times 3 minus 17. Anybody have their calculator? Want to plug this all in for us? That's not right. 112. Aditya. Okay. What did we realize? When we performed the synthetic division, our remainder was 112. When we substituted in that x for f of x, didn't we still end up with 112? All right, when is this going to come in handy for us? When is this going to come in handy? I'll tell you. So the factor theorem, which we already know. So the factor theorem says if we have a polynomial, p of x, has a factor of x minus a polynomial p of x has a factor of x minus a if and only if p of a equals 0. What do I mean when I say p of a equals 0? The remainder is 0, right, when we divide them. But the problem we just did, do we agree it was probably easier with the synthetic division? So when would it be easier not to use synthetic division? I will show you. Let's say I told you, or I asked you, is x plus 1 a factor of p of x equals x to the 99th power plus 5? Okay, so right now, I need you to show work, right? So one way we can do work is use synthetic division, right? If we use the synthetic division, we would take the dividend, x to the 99th power, and divide it by x, the whole divisor, x plus 1. But remember, I have x to the 99th power, which means I have to account for every exponent from 99 all the way down to what? 1. Do y'all really want to do that? Yeah. No. You do? Go for it. I'll check it at the end. Okay. So now we don't want to do that. So that's when that whole concept of, well, if I plug in x to p of x and I simplify it down, that will tell me the remainder. So x plus 1 we're seeing if that's the factor. What did I say to do? Take x plus 1 and solve for x. If we're going to solve for x, x will equal negative 1. So now we're going to plug that in, p of negative 1. So that's going to be negative 1 to the 99th power plus 5. When you raise a negative number to an odd power, what's it going to be? Negative. If you raise a negative number to an even power, what's it going to be? Positive. So do we all agree this stays negative 1? And then you're plus 5. So what's p of negative 1? 4. What does that 4 represent? The remainder, if you took the polynomial and divided it by x plus 1. So our remainder would be 4. So you tell me, is x plus 1 a factor? No, because the remainder does not equal 1. I mean, not 1, 0. Was anybody gonna catch that? Okay. So now I'm going to take this whole concept a little further. I want us to show that x plus 3 is a factor of p of x equals x to the third minus x squared minus 8x plus 12. But then I'm saying, 8x plus 12. But then I'm saying, then factor completely. So, in this scenario, I want to show it's a factor. I can potentially say, okay, well, x equals negative 3, then plug in for x, simplify it down, and if I simplify it down to 0, that means the remainder 0, that means it's a factor. Do we all agree I can do that? But there's a second part of this. It says, then factor completely. If I just plug in negative 3 and simplify that down, will that really help me factor completely? It's not going to help us factor completely. The synthetic division is a much better option here when I ask you to factor completely. So how are we going to go about this? We're going to take our divisor and we're going to set up a synthetic division. Now I'm not going to put 3 in the box. What am I going to put in the box? Negative 3. And then we list out all of our coefficients, 1, negative 1, negative 8, and 12. Bring down the 1. 1 times negative 3 is negative 3. Negative 1 plus a negative 3 is a negative 4. Negative 4 times negative 3 is 12. Negative 8 plus 12 is a positive 4. Positive 4 times negative 3 is a negative 12. Positive 12 plus a negative 12 is 0. Is it a factor? Yes. And then I said, but then factor completely. If I'm factoring completely, do I need my original factor in this process? Yes, in my solution. So I'm going to go back to my original factor, and that's going to be x plus 3. And then I'm going to write my next, what does x plus 3 multiply with? Well, this whole thing. Aren't we going to be 1 degree less than the dividend? So then we're going to be x squared minus 4x plus 4. Is this factored completely? Yeah? No. We can factor x squared minus 4x plus 4. So I have my one factor of x plus 3. Have to include that. Then I'm going to have my other factor. I'm going to factor x squared minus 4x plus 4. So we're going to have x minus 2 squared. Now is it factored completely? Yes. What do you think a common mistake with this is when I ask you to factor completely? Dylan?
Forget the last stuff.
No, people are usually good about it squaring, but I hope you don't forget that, about factoring x squared minus 4x plus 4.
Forget the previous factor.
Good. A lot of people forget the previous factor because it's not fresh in their heads because you just plugged it into the synthetic division. Don't forget the previous factor that we had started with, that x plus 3 in your solution box. All right, last one for this lesson. I'm asking you to find k so that p of x equals x cubed minus 2x squared plus 3x plus k is divisible by x minus 2. Okay, I'm going to opt for the synthetic division here. And what do we need our remainder to be? Keep that in your head. For it to be divisible by, we need our remainder to be 0. Okay, so I'm going to set up my synthetic division, putting my 2 in my box. I have all my exponents accounted for, so that's great. So I have a 1, negative 2, 3, and my constant is unknown. My constant's k. Bring down the 1. 1 times 2 is 2. Negative 2 plus 2 is 0. 0 times 2 is 0. 3 plus 0 is 3. 3 times 2 is 6. This is our last column. Do we agree this last column would then be k plus 6? Right. Now, what do we need that last column, that k plus 6, what do we need it to equal? 0. So what am I going to do at this point? K plus 6 equals 0. So k will equal negative 6. That is the answer. So it says finds k, so it makes it divisible. That's what we would need k to be. All right. That's the end of this lesson. Your homework will be the worksheet that I didn't assign last night. No, I'm going to get started on the next lesson because it's long. But I'm only going to take like 5 minutes of this next lesson. I'm only going to do like 5 minutes of this next lesson. And then you could start the homework, yes. Can I give you a homework pass? No. Okay, so now we are going to be, this is Unit 9 now, Day 2, Higher Degree Polynomials. And the rational zero theorem. Okay, let's say I told you that p of x is equal to ax to the 7th plus bx to the 6th plus cx to the 5th plus dx to the 4th plus EX to the third plus FX to the second plus GX plus H.
Are we sure? Is this multivariable calc?
No.
Same with class.
All right, what is the degree of this polynomial? 7. How do you identify the degree of a polynomial? Good, Dylan. It is the highest exponent. Right? If I were to ask you for the zeros or the roots, all right, if I were to say, I want to know the roots or I want to know the zeros of this polynomial, what am I asking for? The zeros or the roots? What am I asking for? Aditya?
What makes it equal 0?
Yeah, okay, visually. I guess I didn't ask it right. Like, visually, what am I asking for? If it were a graph, when I'm asking for the roots or the zeros, what am I asking for? Aaron? Good. I'm asking where does the graph cross the x-intercept, right? So if I'm saying there's a degree, this polynomial is a degree of 7, doesn't that mean I will have 7 roots? Does that mean they'll all be real roots, though? It doesn't mean that they'll all be real roots because some of them can be imaginary, right? But imaginary numbers, how do you get an I? What gives you an I? Dylan? The root of a negative number. So when you take the square root of a number, what do we immediately have to account for? So like x squared equals something, and then we take the square root. What do we immediately have to put in front for that answer? I heard it. Thought I heard it. When I go to take the square root, what do I immediately have to account for? Plus or minus, right? So what does that mean? Imaginary numbers, when we're finding the roots, they're coming in pairs. Plus or minus, they're coming in pairs. So our complex or our imaginary numbers are coming in pairs. So what does that mean for us? Okay. This means we could potentially cross the x-axis 7 times. All right, so let's figure out our possibility of real roots versus non-real or complex roots. Okay, so what did we just say? The complex or the imaginary will have to come in pairs, because the only way to get the I is to take the square root of a negative number, and the minute we take that square root, we're immediately at plus or minus, right? So can I have 7 real roots and 0 non-real? Is that okay? Absolutely. All right, let's say I had 6 real roots. What would that mean for your non-real root? It would have to be 1 non-real. Is that feasible? Is it feasible just to have 1 imaginary root? No. Why is that not feasible to just have 1 imaginary root? Good. It can't happen because your complex or non-real or imaginary, whatever you want to call it, has to come in pairs. So to have an odd number is not going to work. Yes. Yes. All right, let's keep going. Can we have 5 real roots and 2 non-real or imaginary? Yeah, that works out. What about 4 and 3? Is that a combination 4 real, 3 non-real? Nope, that does not work. Do we get the trend here? What about 3 and 4? Does that work? Yeah, that works. Just keep going since we've committed at this point. 2 and 5, does that work? No, 2 and 5 does not work. All right, 1 and 6? Yes, that works. And 0 and 7, does that work? No, 0 and 7 does not work. Tejas?
Wait, how do you know if it works or not?
Okay, so how do we get an imaginary root? It would have to be like x squared equals some negative number. And then when you take the square root, that's how we get the imaginary. That's how we get the I. But the minute you take that square root, isn't it immediately plus or minus? So now we know all the imaginary roots have to come in pairs. So two loop together, 1 plus, 1 minus. So we're saying, well, is it possible to have 7 real roots and 0 imaginary roots? Yeah, that's possible for them all to be real. So then what about 6 real and 1 imaginary? You can't just have 1 imaginary because it has to have the plus and the minus of that. So that's why it doesn't work. Should I do a little bit more so it's less work next class?
No. I'm so tired.
We can carry on fresh on Monday.
Yeah, that's a good idea. Or Tuesday. No, we really start homework now.
I have a horrible video to show you though.
What? Can I sleep? Do I have to like wake up?
Okay. I'm going to show you one thing and then we'll start the next class with the horrible video. Okay? I'll sort of leave you on a cliffhanger. Okay. The rational roots of this theorem. Zero theorem. Sorry, rational zero theorem. The rational zero theorem gives us a way to get a list of all possible real roots. I'll explain. Oh, actually, it's not all possible real roots. It's all possible rational roots. So let's say I have 2x cubed minus 5x squared minus x plus 6. How many possible roots, or how many roots, not possible, how many roots will this have, this polynomial have? How many zeros will it have? 3. Why 3? How do we know? Because it's the highest degree. Does that mean they'll all be real? No. Okay, so what the rational root theorem tells us is a way to get not all the real roots, but a possible rational roots. And how do we do this? It's the factors of the factors of the constant over the factors of the leading coefficient. And we call this factors, we call the Q the possible factors of the leading coefficient, and we call P the possible factors of the constant. So this is also known as P over Q. I know, it doesn't make sense. Just follow with me. Right now it's not making sense to you. Okay, so what we're going to do is we're going to go to the constant. What's my constant? What's the constant? 6. Let's go through all the factors of the constant. Do you agree we could do plus minus 1 and plus minus 6? 1 times 6 is 6. All right, let's keep going. We could do plus minus 2. 2 times what is 6? Plus minus 3. Are there any other factors of 6? That's it, right? So we got factors of our constant. Now we're going to go to factors of the leading coefficient. Well, my leading coefficient is 2. What are the factors of 2? Just plus minus 1 and plus minus 2. Okay, so now what we're going to do is we're going to take every numerator and pair it with every denominator. So we can have plus minus 1 over 1. We could also have plus minus 1 over 2. Do you see what I'm doing here? Then we could have, now going on to the next numerator, we can have plus minus 2 over 1 and then plus minus 2 over 2. But what's 2 over 2? 1. Isn't that already accounted for? Do I have to write it again? No. Let's go on to 3. We could do plus minus 3 over 1, which is 3, and we could do plus minus 3 over 2. Then we go on to 6. We can do plus minus 6 over 1, and then plus minus 6 over 2. But what's 6 over 2? 3. Don't we already have that? All right, so what this gives us, this is the list of all possible rational roots. Meaning if there is a rational root, meaning if our graph is going to cross the x-axis at a rational number, it will be in this list. So let's go. I'm going to stop recording here. This is really it. This is